Good afternoon, everybody, and thanks for making it. You're on the home stretch to the end of Black Hat here. I'm Dan Hubbard. I'm the CTO at OpenDNS, and with me I've got Andree Toonk, who is the head of our network engineering group at OpenDNS, and more importantly, the founder of BGPmon. So today we're going to go over a number of things. Of course, with the big highlight, we're announcing BGP Stream. But of course, we're going to give you a little bit of background on BGP. We're going to tailor that down a little bit because there's been a few, surprisingly, 3 BGP talks at Black Hat this year. So hopefully you've already got a pretty good understanding of how BGP works. Then we're going to go into some attack examples of BGP, some that are very new and very have been released, very interesting on the timing. Then we're going to talk about BGP Stream. What exactly is BGP Stream? Go over a client that we've written which utilizes the feed like an external consumer, like you may be. And then we're going to, we have another announcement that has to do with DNS that is very similar to BGP Stream. Before I hand it off to Andree to kind of get into the BGP details, just a little bit about us. OpenDNS, of course, is a company which allows you to point your IP addresses at us and get fast, safe DNS. We've got a little over 60 million people around the world that do that every single day. And you'll see in the back of our business cards, on the back of our shirts, and all of our swag, the 2 IPs you can obviously point to us. And we were fortunate enough to acquire BGPmon earlier this year, which essentially operates a number of probes around the internet, which are looking at the BGP tables, all the networks, the autonomous system numbers, and the associated routes and best paths to get there, and then compares those changes and allows you to monitor your networks to see if somebody is hijacking your IP space that you potentially may not know about. They, of course, also monitor and manage outages and inform you of that. So the 2 obviously have a lot of synergies, and of course we're utilizing the data in OpenDNS from BGP in order to better alarm our customers when events are happening, and of course to increase our efficacy of blocks, that stuff. So with that, I will pass it over to Andree, and he'll start off with kind of the 101 of BGP.
Awesome. Thank you, Dan. I hope you guys like my t-shirt. We have a bunch more. Everyone who has a good question gets one. So first of all, BGP 101, maybe you already noticed, just want to make sure we're on the same page. So what does the internet look like? This is a picture of the internet, one of many. But what you can see right away is that it's a graph, and each node in this graph is a system. So in the world of BGP, when we talk about a unique organization on the internet, we talk about autonomous systems. So an example of an autonomous system is OpenDNS, Google, Facebook, Comcast, AT&T, all these sort of unique organizations, ISPs, content providers, enterprises that want to participate in the world of BGP have an autonomous system. So an autonomous system is identified by a unique number, either a 16 or 32-bit number. Here are some examples. 36692, for example, is OpenDNS. These numbers are assigned to you by the same organization that assigns IP addresses, ARIN, RIPE, etc. They have no further special meaning. They're just a unique identifier. So at that point, once you have an autonomous system, which sometimes is called an AS or an ASN or AS number, we start announcing networks, which in the world of BGP we often refer to as prefixes. So if you hear me say prefixes, all I mean is like a network range. So every autonomous system should at least announce 1 prefix, but typically more. It could be V4, V6, it could be a single one, it could be multiple thousands. So at that point, once you are connected to the internet and you have a BGP-capable router, you need to connect to an internet provider, someone that connects you to the rest of the network. We call those typically transit providers, peering. And once you start connecting to these other networks, you start forming this graph. So right now, there's about 500,000 routes out there on the internet, and about 50,000 unique autonomous systems. So if you want to say, for example, you're on the left-hand side of this graph, and you want to go to Facebook, which happens to sit on the right-hand side or so, the routers on the internet need to know how to get there. And that's where BGP comes into play. Each router on the internet talks BGP, and they exchange route information. This basically means, hey, I'm OpenDNS, I have these prefixes. If you have any traffic for it, send it to me, because I know how to get there, I own these prefixes. prefixes. So then everybody starts relaying those messages, and we often call BGP a gossip-based protocol because we just start relaying all these messages. And then BGP routers are able to form a map of the internet, similar as you can see here, and can find their way around. So we look at the next page. So this is an example of a real router. This is one of our routers in Sydney, and I asked it, can you tell me the route to facebook.com? So the first BGP route. The first thing it did, obviously, is translate that to an IP address, and it figured out that IP address lives in this particular /24. It then said, oh, in my BGP routing tables, I have 3 possible options, and I've colored them in 3 different colors. The things to look for are the underlined ones, called AS path. So the first option is the best one because the AS path is the shortest. It only has one AS in it. In this case, this AS is the AS of Facebook. So this would indicate that we are directly connected to Facebook, we peer with them, which is great. So we have really short paths to them. If that path becomes unavailable, I have 2 other options. And the thing to note here, so that's the green and the blue one, is that the same AS shows up as the last AS, the most right-hand AS in the path. So that's, again, indicating that this prefix is originated by Facebook, which is 32934. So now we basically have a pretty good picture of how BGP works. We have autonomous systems, they connect to each other, they exchange routing information, and a typical router, if you're multi-home, has multiple options. And then by looking at all this data, you can infer all kinds of interesting things. You can figure out which prefixes are out there, who's announcing them, when did they show up. And by looking at just the path, for example, you can figure out certain business relationships as well. In this case, I know that 1221 seems to be always providing connectivity to Facebook in this case. 1221 is Telstra. So I know that they buy connectivity there. So you can find all kinds of interesting things. So this has been working, obviously for years. BGP has been around for a long time. It's been working relatively well. The problem with this is, like I said earlier, it's a gossip-based protocol. So I just have to believe that what my neighbor is telling me is true. It's very hard for me to verify that that's actually the truth. And people lie on the internet. And there's several well-known examples of where this happened. So I want to just go quickly over a few of these. What happens when people lie on the internet? Now, one of the examples is, so there's different use cases. One of them is spammers. The biggest problem for spammers is clean address space. How can I send spam and, I obviously end up on a blacklist or a spam list, spam house, spam phone, and after 24 hours or so, that space is unusable. So this is a real-life example where spammers basically started looking for unused address space. And even though we're running out of V4 address space, there's still lots of ranges that are not being announced today. They're not visible in the BGP routing tables. So basically, they identified those, started to announce those at 8 prefixes at a time for a few hours, started sending spam, stopped, started the same process again with 8 new prefixes, and somewhere between a few hours to 24 hours. And they literally did this for weeks at a time. So for them, they basically got an almost infinite amount of clean address space. They would just use it for a few hours. At the time that the abuse messages came in, they didn't really care because those abuse messages would go to the people that actually own the prefixes. And they were like, I'm not actually using these networks, so a lot of people were confused. So we worked with the providers involved to shut this all down. But that's one particular use case. The other one is BGP hijacking for financial gain. This is an example of work originally discovered by the guys at Dell Secure Works around this time last year, where it was discovered that an ISP out of Canada was hijacking space for well-known cloud providers such as Amazon and OVH, DigitalOcean. And those machines were being used as Bitcoin pool servers. So miners would check in with the pool server, get their assignments, do their work, and get the report. The problem was they weren't really talking to the real pool server. They had hijacked the IP address of the pool server. Still doing the work, but didn't get the reports. And it is estimated that they made, I think, about $80,000 with this. So another example where people are actually using this for malicious purposes. Another example, hijacking by governments. This is something that hit us personally, as well as some of the other popular DNS providers. About 1.5 years ago, there were elections in Turkey, and there were things on the internet that the Turkish government didn't like, on YouTube, Facebook. So they said, okay, we need to censor this. Now, what do you do as a country when you need to censor something? We don't all have a Chinese firewall, but in the case of Turkey, 90% of the internet reaches, or the users in Turkey reach the internet through one provider called Turkey Telecom. So if you are able to do some kind of censorship there, then you basically censor most of the country. What they did is censorship on the DNS level. So most people were using Turkey Telecom DNS servers, saying if you go to YouTube, don't give them this real IP address, give them this other IP address, and as a result, it didn't work. People in Turkey pretty quickly found out that if you change to Google or OpenDNS or some of the other free recursive DNS services out there, you're able to bypass this restriction. And as a DNS geek, it was really cool to see when people were spray painting DNS IP addresses on bus stops and walls, and this became super popular, and we saw a huge increase in traffic from Turkey. But obviously the government figured out what was going on, and they decided to block our IP addresses and Google's IP addresses. But at that point, because so many people had changed their DNS servers, the whole internet experience for those users was broken, because we can't talk to a DNS server. It looks like the whole internet's down. So they quickly reversed that, but then the next day they came back, and what they did, they hijacked the IP addresses of OpenDNS and Google's 888 and some of the others, redirected it to a server that they controlled, actually running a DNS server, and now applying the same censorship there. So think about that for a moment. What would happen if someone would announce your prefixes for your bank or a popular website and claims that he's you? Right? That's a very scary thought. There's not much you can do about that, but it's very important to be aware of it. Luckily, this went away after a few days, and we haven't seen it since, but we still have a lot of users in Turkey, so that's good. The other thing you can see in BGP is large-scale outages. During the Arab Spring, we saw many outages in Syria, Egypt, where the country basically went offline for a full day, multiple days. And we still see them happening in Syria and Iraq almost weekly. BGP is the protocol where you can see these things. Routes will just disappear, and you can tell exactly which timestamp this happened, which providers were involved, and the sequence of things. On our blog, you'll find many, many more examples. BGPmon.net/blog of BGP hijacks. The one I want to focus on now a little bit is something we blogged about a few weeks ago, hacking team. So obviously, I'm sure most of you have heard of hacking team. It's basically a hacking team for hire. Governments, law enforcement use them. They get owned, and a lot of their documents are posted in WikiLeaks. As part of that, it came out that they actually used a BGP hijack as well to recover some of the remote access tools, infected clients. So what happened is they had this tool installed compliance. This tool was calling home to a server, which was hosted in a cloud provider called Santrax. This cloud provider went out of business. So they had these infected targets, but they couldn't call home anymore. So obviously these were valuable targets. So what they set out to do is basically say, well, we'll just take that same prefix, we will now announce it, set up a server so that the clients can call home again, and we can reconfigure the clients. So I have a visualization of that here. This is what that looked like. So this tool is called BGP Play, and it's an open source tool, modified it a little bit for our use, but what it shows is basically the sequence of events, the timeline. So in this particular case, 3104, it's called Aruba, it's the Italian provider that was announcing this prefix for them. And then on the bottom here, you can see a timeline with all the events. So this happened for about a week. You can visualize what happened, which providers were involved, the exact timeline. We're now hitting August 22nd, which is sort of the end of the operation. At that point, they had reconfigured the clients. They were able to talk to them again, and they were undoing what they're doing. You see a lot of red things at the bottom there. That means withdrawals, and they were done. So this is another kind of interesting example of a BGP hijack. So with that, obviously there are many examples. I could go on for an hour. But one of the things I often hear from people that use use our tools either for free or paid for, is I got this alert, my network got hijacked, am I the only one that was affected? Were there others? What was the scope and impact? Things like that. So we set out to sort of help answer that question, and also feedback a little bit more, or submit back a little bit more information to the community in general. What things are happening on the internet? We can find large-scale outages, hijacks, and things like that. So we built this tool called BGP Stream. It's on Twitter. You can follow us at BGP Stream, where we publish these events. So the events that I just talked about would have shown up. We only just recently started populating data, but there's already a few interesting examples. So let's just take a look at the Twitter page here. So this is the Twitter page, BGP Stream. You can follow us there. And again, large-scale outages and hijacks. You can click on it, and it will bring you to bgpstream.com, and then it has an event ID. I want to just show a few interesting ones. So this is an example of a possible BGP hijack, where we were looking at 38/8, which is normally announced by Cogent. And on this particular day, a few days ago, we noticed a /22, which is more specific, announced by this particular AS, 263749. So you can see the exact timestamp, when it happened, example AS path, how many of our probes saw this. Then you can also replay the event, as you can see here. And again, this is the BGP play tool. And you can exactly replay it. Let's take a look at this, for example. And you can hover over all these things. And then, obviously, we already knew which provider was involved, but now we can also see its upstream provider, which is in this case. The screen's a bit small, but again, you can then see who this is. It's also over there. It's in Columbia Networks, but it just falls off. Again, you can visualize everything here and see exactly who's involved, the timelines, if it was maybe for 10 seconds or for 2 hours or days. So that's an example of a hijack. Let's take another look. This is an example for a country. This is actually something that just happened earlier today, where we saw a large-scale outage in Angola. It started here. It affected 68 prefixes, which is about 38% of the country. And again, you can replay that here, fast forward. So here you can see the outage started. If I play it here again, you can see at 14:56, and then at 16:25 it came back. So you can really nicely see the pattern of things happening here. If we have enough traffic for a certain country, we will also show you the traffic patterns that OpenDNS is seeing for this country. And then if the outage is large enough, you'll see a significant drop-off, as you can see here. Again, this is an example from Guatemala. But, you can just click around. This is our main website, bgpstream.com, and then obviously you can go under there and you see all the events. What you see here at the main page is the basically state of the internet right now as it happens. These are all the active outages that are happening right now, and we group them by country. So here you can see that Mauritius, for example, so the size of the red dot indicates how large the outage is. In this case, Mauritius, 6% of the networks are unreachable. Iraq, always unstable. And so if there would have been a large outage in, say, Syria, it would show this giant red dot. So it immediately shows you sort of what's going on. And then again, here you have all the events that showed up in Twitter. You can click on them and see the details. So that's pretty cool. How does it work? So the problem when we started out with this is, let's take a look at how it works. So on the right-hand side, you see lots of routers. So we get feeds, BGP feeds from lots of different providers in the world globally. And then, so that's what we observe. And on the left-hand side, you see the expected state. That's what we expect to see. And if there is a difference, then we start comparing that. We feed that into our analyzer and classifiers and try to figure out how big of a deal this is. Is this just a customer announcing the provider space that they probably have been allocated? Probably not a big deal. If they've done something similar in the past, probably not a big deal. But there's certain things we need to look at. And this is very similar that we do with our regular monitoring system. The regular version, though, people tell us what is expected. In this case, if you do it for the whole internet, you kind of have to guess what is expected. And when we started out, we basically had a fire hose of events, hundreds of events a day, and we really set out to make something useful, actionable, so whatever shows up is actually highly suspicious or interesting. So, as I said, the big challenge here was trying to figure out what is legit and what is a false alert. So I just want to spend a few minutes on how we classify that. So basically, for example, think about you're a customer of Level 3. Level 3 is a large provider. If I need more address space, I can go to them and say, hey, can you give me some more address space? And say, sure. And they'll give me a little chunk out of their large network, and I start announcing that. In theory, that would look like a hijack, because now I am announcing Level 3's address space. Obviously, that's not really a hijack. It's kind of expected. So we look at, does this event are there any existing business relationships between the expected origin AS and the detected one? Are they customers of each other? Is there an existing business relationship? Did they recently announce prefixes of each other? So we can guess if this is something that is expected or not. There's also sort of well-known cases where prefixes move between ASNs all the time. There are special 624 any-class prefixes, for example. Or, very interestingly, the US Department of Defense, obviously they have large address space, but they also have a few dozen ASNs that they actively use. Very interestingly, these prefixes move between ASNs quite regularly, so we suppress those kind of things as well. Other things you can look at is WIS information, very similar as DNS. IP addresses have WIS information. There's route objects, there's all kinds of allocation data. We look at that as well. We look at name collisions and the different WIS records for this AS and this AS. Is the name similar? Do they have the same email addresses, and so on and so forth? And then finally, we look at GeoIP information. You can imagine that even a prefix geolocated to the Netherlands is also announced by another AS out of the Netherlands. That may not be that suspicious, but if it's an ISP out of Canada and all of a sudden that prefix is announced out of China, that obviously is a little bit more suspicious. So there's different heuristics where we look at. For the US, obviously a lot of IP addresses geolocated to the US, so there we also look at state. And then we can look at the number of BGPmon probes that detected all of this. So with this, we think we have a pretty good balance between suppressing false alerts and also surfacing relevant and interesting information. We're still tuning it, but I'm pretty happy with the results so far. So that's it for me. I'm going to hand it back to Dan. Thank you. Show some interesting visualizations.
All right, so the genesis of this project actually was we have hackathons every once in a while at work where basically people are taken off of their regular job and given 24 hours to do whatever they want. And BGP Stream was one of those projects. So once the BGP Stream team created the Twitter feed, we started thinking about, well, what if we weren't, part of the BGP Stream team? We were an external entity. How would we consume this data? Besides using our favorite Twitter client on our phone, on our laptop, or whatever, is there another way that we could actually programmatically use the API and take the AS information, the AS changes, and then do something more interesting with that data to figure out more about the attack? So we created a way to connect to Twitter through the API, grab the AS number, and actually the way we format the data is both human readable and programmatically well done. It's comma delimited. So we pull the AS, we pull that into a system that we have internally, and we run it against our intelligence API to find all the connected graph of all of the data. So with an AS, you start off with that number that Andree talked about, the ASN. Then from the ASN, you need to find out what all those prefixes are that they're announcing. Those are all the routes and all the networks that they own and what they're announcing and where they're announcing them. Then you take all of those, we look at all the domains that they own, look at the name servers they own, look at the whois information and all the IP addresses and everything else, and then we graph all of that information together. Now, you can do that in one of our products with a textual interface, but we also have a way to do that visually. And humans can consume pictures a lot better and can interact with pictures and information in a lot more meaningful way than you can when you're looking at text. It's really hard to build a picture of what's going on with just all of this massive amount of text, whether it's a JSON blob or something else. So let me demo that for you. So the way it works is essentially we pull the ASN and we do a bunch of parsing of that data, run it against all of our stuff to build the graph. Depending on the size of the ASN and the amount of domains and IPs and everything else, it can take a while. It can take upwards to 5 to 8 minutes at the most. If there's not a lot of data, it takes like 30 seconds. But I kind of sped up the video so you don't have to sit here for 10 minutes watching it build, but you'll get the idea. So this is basically the tool running. This is now going to get all the relationships of the graph, building the JSON file that gets consumed into this tool. So this tool is a tool that we open sourced last year at Black Hat. It's called Open Graffiti, opengraphiti.com. It is based off OpenGL. It also supports WebGL, and I highly recommend if you do any visualization that you check this out. But this basically allows us to consume all the relationships and visualize it and build the graph. So this is basically starting off with the AS, pulling all the prefixes, pulling all the networks of domains and the IPs, and then you can do things like, let's look at what the different node types are. What's the color? Let me color code, let's say, all the name servers versus the domains versus the whois information. And then you can interact with the information in real time. So that AS right there in the middle is 17216. And that was kind of one of the ASs that we pulled off the BGP stream. We pulled it in, we parsed all the information, we found all the relationships, and now we're graphing it. And in theory, a researcher is looking at this information and figuring out what the problem really is and what those related components are. But this isn't that big of a data set. So then we did a better one, which is actually GoDaddy, with the GoDaddy AS and all the kind of suspect domains and IPs around the GoDaddy AS. So you see as the graph builds, essentially what the graph is doing is repelling and detracting all of the relationships within the graph. So right in the middle is actually the GoDaddy ASN, and then we're building up all the associated IPs, names, and categories of all those domains of that autonomous system number and visualizing it. So right away you can start looking at the edges of the graph to find out what the relationships are, and are there pockets of badness within that autonomous system number where you can just graphically go and figure out where to hunt for more information. So it's a great example of a client that we wrote that allows us to utilize the BGP stream feed. So BGP, awesome. We acquired BGPmon. One of the largest pieces of BGP data that's out on the internet. However, OpenDNS obviously is very well known for DNS. And as I said, we operate a lot of data centers around the world. We've got 25 data centers around the world, and we service a little more than 2% of the world's DNS traffic. So that's a lot of data. So it would be kind of evil if we didn't do something in DNS that was kind of like BGP, because there's a lot of problems in DNS like there is in BGP. So we also run DNS. And our kind of satellite view of the internet today, we see about 80, that's a real-time graph of our connections. That's on our website. That's the number of lookups that we're servicing. We've got a very diverse set of users. We've got home users. We've got ISPs. We've got the top companies in the world that use our service. We have EDUs, etc. That equates to about 80 billion requests every single day in 160 different countries. And there's about 65 million people that point their DNS at us every day. And what that means is, like BGP, DNS is a pretty low-layer fabric of the internet. If DNS goes down, the internet doesn't work so well. People don't like typing in IP addresses. So every message you send, every tweet you send, every website you go to, of course, the very first thing that typically happens is BGP. You got to find out where you're going, and then DNS happens from there. So let's talk about some of the attacks that have happened. Like BGP, there's been a number of attacks. There's actually been quite a bit more attacks within DNS. It's a lot more popular way to attack folks. This is a kind of an infamous event that happened with Twitter, Huffington Post, and the New York Times. So allegedly, the SEA, or Senior Electronic Army, took over the registrar, which was a company called Melbourne IT in Australia. Why they were using Melbourne IT, I don't know. But essentially, they figured out a way to get into the system that actually had the registration detail of their name servers. And they pointed all of these properties' traffic for their name servers to the SEA name servers. And that's what that IP address is at the top. So actually, we used Open Graffiti here to visualize the relationships between these. These properties are not connected. They're not owned by the same people or anything, but they became connected. And they became connected through this bad name server that was being run by SEA. Now, the kind of comical side of this was that they had like 2 web servers and like 2 servers sitting there, and taking the New York Times, Twitter, and Huffington Post is not going to last long. So the servers died like literally in seconds because they were taking all of the traffic. But this took a while to unwind on the internet. We had a lot of people on the phone. It was nighttime in Australia, and we had to kind of unravel, this whole event with a number of kind of big people out there that are running the internet. Another more recent example was, January of this year, Malaysia Airlines had a problem from everybody's favorite Lizard Squad. So the Lizard Squad did not deface Malaysia Airlines website. What they did was they took over their name servers and pointed to the Lizard Squad site, which had the Lizard Squad character, logo, whatever you want to call it, on their site. So essentially what happened was we saw the IP address that was being staged in December, and this IP address was actually a name server which was hosting and announcing all kinds of web properties that were good properties. But who really cares at that time, because no one was going there. But in January, when they hacked the registrar, they changed the name server to point to Up Malaysia Airlines to their bad IP, and therefore everybody that was going to the real Malaysia Airlines was going to the Lizard Squad site. And the last example was yet another kind of government example where the Hong Kong government was going through an election, or attempting to have an election, and they were doing some of the voting via popvote.hk, which is a website that they were running. And that website basically came online, nobody knew about it, then they started announcing it, hey, here's the place about voting for the Hong Kong election. And as soon as that happened, literally like an hour later, they had 750 million DNS requests within 1 hour. So there was a massive kind of exhaustion attack against popvote.hk, and in turn rendered the site useless. You couldn't actually go to the site anymore to attempt to vote. So with that, we are also announcing DNS Stream, which is like BGP Stream, is also on Twitter. Twitter is a great way to announce things. There's all kinds of, obviously, clients that you can use. It's a great human interface. It's a great way to share data. But also, it's a great way to programmatically consume information also. So let me show you DNS Stream. These are all open, by the way. These were closed. If you guessed BGP Stream was a Twitter handle, or DNS Stream, they were closed for a while. They're all open now. They're not private. So currently there's really 3 types of things that we're working on announcing. These are really focused on kind of the Alexa 10,000 sites, because there is a massive amount of DNS issues out there, and the signal to noise ratio is pretty bad. So the first one is when a name server of a company is changing to a different name server outside of kind of that provider of that name service. So that's what we call kind of a critical event, where essentially a whole name server changes. So you can see some examples here. Critical, these guys' name servers are changing. This, I will note, this does not always necessarily mean that something bad is happening. People change their name servers, that does happen. But there are ones of note where, let's say, someone huge like a Google changes their name server to an AS which is outside of the Google AS. That's actually potentially a very critical event. And like BGPmon, we can announce these with the location of where this is happening. So that attack may be happening regionally in some location, and we'll announce the specifics. We're also announcing DDoSes, so a resource exhaustion attack. Because we are an open DNS recursive service, we see a lot of DNS attacks, because people will bounce an attack off of us, or potentially people will have their DNS pointed to us and be hammering the intended target. Now, we can take the brunt of that attack, but we have an algorithmic way to identify people that go from like 0 to 10 million, and we will throttle that traffic down, or potentially block the traffic going to that, in order to help that inevitable target be blocked, and of course not to affect our service. We also, let's see, these are all happening in real time. We also will tell you if, let's see if I have one. Oh, there's none right at the top here. But we also will tell you of an event where a major website or major A record IP address is changed, so something is malicious. So let's say Twitter.com was taken over by the Syrian Electronic Army, and not just their name server, but also the IP address changed. And it changed to somewhere that had a bad IP address that we had classified or categorized as bad previously. We will announce that also here. So all that information is on DNS Stream, and we are announcing it in real time. So a lot of cool information that we are announcing and building up. So the future, what are we working on? Although this was kind of a 24-hour hackathon project, clearly we spent a little more time on it than that. And we are going to continue. Our first priority really is around tuning and training. As Andree said, a lot of these services sometimes they seem really cool at the beginning, but you just get this fire hose of so much information, and it's really hard to ingest that. So we're trying to figure out what the balance is of kind of critical events, informational events, and then just things like outages. And then, where does that stop? Where do we do only the top ones? Is it the only Alexa 1000? Is it the 10,000? How far down do we go? Programmatically, it may not hard to ingest that, but certainly from the human perspective, it's very hard to ingest, tens of thousands of tweets per day. So tuning and training it obviously is one thing we're doing a lot of work on. We're also looking at integrating DNS Stream into the BGP Stream portal. Right now, DNS Stream only will give you the data within Twitter, and 142 characters is very limiting. We can only tell you so much about an attack, but we didn't have time to complete that integration. So you will be able to click on a DNS Stream event, and it will take you to the portal and have a bunch of information there. And then lastly, and probably most importantly, the goal here really is to build a community of kind of BGP and DNS watchers. So Twitter is great to follow people, also to retweet, and to maybe DM us about events that you know about, or announce events, or potentially write your own stream of some sort. Maybe it's malware hashes, maybe it's compromised sites. I don't know what it could be, but it's hopefully a way that people are going to get used to publishing information. And you hear a lot about people talking about, hey, we need to share more, we need to do more, cooperate more. Well, this is one of our contributions back to actually announcing information that we believe is digestible and important, and hopefully add value to you. So with that, we will take questions and then hopefully get you to your lunch. And we've got some Run BGP shirts here. We don't have any Run DNS shirts, but we have Run BGP shirts. Yep, go ahead.
Hi, I have two questions here. First question is, have you considered contacting the whois information associated with people that are getting hacked that they might not necessarily know?
Yeah, so we actually have whois data. So we do know that. Contacting people always sounds easy, but sometimes it's very hard to do.
Right.
So this is one thing that they could do. They could watch their brand to see if their brand shows up in the stream potentially to do that. But obviously, if you buy our services, you can monitor your own properties in a much more eloquent way with a lot more detail than this.
Right. The other question is, are you going to be offering a curated stream of any sort, because that is kind of the fire hose, and there's a lot of domains I'm not going to care about, but
the answer is no. So we are technically curating the data. If we didn't curate this data anyway, technically, it would be so much information you wouldn't be able to consume it. But we are going to work on how to get that balance of tuning the information.
Or you do a separate stream for one more.
Yeah.
Thanks.
Thank you. Oh, here's your shirt.
Okay, I have a BGP-related question. In your alarm criteria, you were always talking about the originating ASN. If somebody is announcing a foreign PI space or something, is he really using his own ASN, or isn't he just faking a link to the real ASN and announcing it so it still originates fake from the right ASN but from the wrong path?
Yeah, sure we can email. Yeah, you can do both.
So your criteria is always saying you look at the originating ASN. So are you also looking at the next hop?
Well, actually, in the case of the hacking team Italia one, they used a different AS. So it was normally announced by its hosting provider, and now Aruba, which is another Italian provider, was announcing it. So it's very clear that there was a difference.
Yeah, but they could easily fake a link to the real ASN and announce it from there if they are controlling of one ASN.
Correct. So you're saying you could spoof the AS path.
Yeah. So,
Yeah, you can do that.
so what is usually happening? Is usually happening announcing from the fake AS, or are they usually announcing from their own?
Well, most of the cases, there's plenty of cases where they're announcing it from their own AS. So it's very, you can see immediately that there's a difference. There are cases where people actively try to hide it, which is exactly what happened using the Bitcoin hijack. We're actually spoofing it with the actual AS. So with just looking at the origin AS, it was hard to find. You have to do full path analysis.
So you look at the path also?
We do.
Because
that's not included here, but in our commercial solutions, yes.
Yeah, okay. Yeah. Thank you.
Sure.
Andrew, thank you for a very nice talk. And thank you for what you're doing. Very interesting. One side note, yes, AS pass is also really important. And I noticed in one of your slides that you try to measure AS relationships. How do you qualify that? Is it just connected, not connected, or is trying to classify as the experience, as customer-provider relationships, and so on?
Yeah, right now if there is an existing business relationship, either customer, provider, or peering, then we say there is a relationship because it's a heuristic that appears to be very useful. So right now we don't make a distinction between peers and providers.
Because when you try to guess if there is ASPAS alterations, this is absolutely necessary prerequisite. If you don't know this information, you could not tell if this ASPAS was altered or not. And another question is, with this Twitter stream, there was a lot of simply randomized domain names for .cn. What's up with that?
I don't know. I'm not sure. I haven't looked at the data. This is
Goddamn
all happening in
Chinese.
real time. Like, it's now.
If it's happening now, yeah.
Get them
Have to look at
Chinese. You might get a lot of noise out of China. Just a word
Oh,
of
yeah.
warning. May have a BGP shirt.
Oh, yeah.
Yeah,
Oh, that's probably too
let's go here.
Yay, goodies.
big. Go ahead. Next question.
You started talking about how hard it is to recover from a hijacked BGP route. I'm wondering if your hope is that this will make it easier with greater transparency, greater visibility and community. It'll help recover, and if so, how?
I guess that's not really the intent. I mean, we're really trying to provide visibility, but typically to recover from events like this, you basically have, the first thing you'll do is reach out to the AS that is hijacking you and say, hey, what the hell are you doing? Can you please stop doing this? If it's an accident, which is fairly common, then you'll probably have the success with that. It's like, oh, what the heck, let me undo this, and sorry about that. If it's intentional, they're probably never going to reply. So then you'll have to reach out to their upstream providers and say, hey, your customer is doing this, why are you accepting this? And then typically that is the policy or the common practice to do. But that is a longer route and can take hours. Yeah.
Great, thanks.
Hi, thanks for your talk. I suffer an accidental BGP hijacking because somebody don't pay the bill and the ISP provider took everything, the ASN number too. So is your Twitter account and your BGP stream site are focused on this unintentional hijacking too? So maybe we can.
It could be both, right? Yeah, sometimes it is unintentional.
Yeah. Like 9 out of 10 cases, I'd say, are accidental hijacks. But for you as a user, it doesn't matter because the effect is exactly the same.
It took about 4 hours to solve my problem because when we called the ISP, they said we have no attack. It's no problem. You haven't paid. Stay quiet. And the problem was they are hijacking some TLD registers, and half of a country, I don't want to say where I came from, was without internet. It's in South America.
Yeah, if it looks like a real hijack, we will report it, but at the same time try to suppress false positives. Yeah.
The cool thing about Twitter is if you see an event like that, someone could always retweet it and add a comment like, "Hey, I'm in this country. This is actually
Yeah,
happening."
and many ISP don't understand the importance of BGP. They see as an independent layers for network administrator, nothing to do with DNS and all things. That's
Well, ISP should know BGP. That's kind of bad.
they should.
Thank you.
I was curious on the GoDaddy visualization. There were some unconnected components. I was wondering if you could talk about like what those were and how those happened. Like, are they?
Yeah, so not everything will always be connected. Like there may, for example, let's say I have we look up things like whois information. So we return back all the whois data, and maybe they registered a domain that's from a different whois record that's somewhere else. It's just not connected to the graph in some way. Yeah, that always happens. The good thing about the visualization is you can drill into the components that are connected to see if there's similarities.
And then also, I know your OpenDNS has DNS crypt, and are you trying to propose anything to help secure BGP?
Yeah, so just to be sure, the DNS crypt is actually not like a way to authenticate clients. DNS crypt is actually about encrypting DNS, the actual protocol itself, across the wire. Authenticating it, BGP is what? RPKI. Unfortunately, a lot of people don't use it. So
RPKI you can sort of consider as DNSSEC for BGP, but it's very new. It's also remains to be seen if people believe in it. It's somewhat controversial, so it's too early to tell if it will work out. Yeah.
Thank you.
And I'll have a T-shirt for you here.
All right, I have two questions. First of all is, I'm assuming that BGP, a larger prefix, has, like a more priority, like if you're announcing a /16 and then announce another 20, like a /24 out of that, it would have higher priority, correct?
Correct.
Would it be possible to unhijack, like let's say someone had hijacked your address space, could you announce even a more specific prefix and unhijack it that way?
Yeah, that's great. I should have mentioned that earlier. That's one of the first things typically people do. So if you have a /16 and someone announces a /24, then, let's say 23, then you can announce /24 and you'll get all the traffic again. The problem occurs at the /24 level. That's sort of considered the minimum or the maximum range that you can announce. If you do a /25, it typically doesn't propagate everywhere. You'll get it somewhere here and there. But basically, it's considered the /24, and then that defense no longer works.
Okay. Yeah. And then my other question is let's say you don't have your own ASN, how hard would it be for someone malicious to like add BGP routes, not having their own ASN? Like the hacking team, I'm assuming probably doesn't. How hard is it to get BGP traffic into a router?
Hard. Yeah, you would have to own a router basically. Okay. So you have to have an AS.
you have an AS to use BGP.
Yeah. Okay. Unless you just want to hijack.
Unless you like add your own routes in the router.
Yeah. I think this is the largest.
Hey guys, you mentioned seeing like a drop in DNS for a particular attack, post BGP attack. Is there any other ways that you've found that you've used your DNS data to kind of fill in a story of what happened surrounding the BGP attack?
Oh yeah, actually, one of the examples that didn't come up that is really interesting sometimes is, so what you may see is that in the DNS side, we may announce that there's a DDoS happening against a particular domain. And shortly thereafter, you'll see the name server change because now they're like, oh, let's shed the load off to be another name server. And some of the DDoS providers either do it via DNS, and then other ones do it via BGP. So VeriSign and some of the other technologies out there, they actually announce, and you use your AS to announce. They announce you in your IP space in order to take the traffic away from your thing that's getting targeted. So yeah, BGP and DNS on DDoS for sure is definitely connected.
DDoS, and in terms of outages, that's quite interesting. You can see it in BGP because the prefix just becomes invisible. They're all withdrawn. In terms of DNS, obviously we will see a drop in queries from that particular country, like Syria or Turkey. But at the same time, we would also see a huge increase in what we call serve fail queries to the clients for TLDs or domain names that are hosted in safe domains. So there's multiple things that we can look at with that whole story together.
Thanks, appreciate it.
Couple more comments. First of all, if you think
You don't get
you're,
another shirt.
if you, if you think that announcing /24 solves the problem, it's not. Attackers can do just the same, and none of people will hate you for that because route table space explodes. If everyone knows /24, we're done. That's
Depends
one
on the
more.
upstream's filtering, right? I mean, the upstream
Yeah,
decides what to
and
filter out.
upstreams will aggregate as
Yep.
a response, and it doesn't get us anywhere. And the other thing is RPKI isn't used because it doesn't solve the problem. Frankly speaking, it allows you to only control the origin. It doesn't allow you to control ASPAS. So it's not a cure, so no worries that it's not used. But it's really important to understand that it doesn't solve the problem completely. Otherwise, people enable RPKI and they receive this false sense of secureness when they are not. And it's the worst thing that can happen to security technology, in my opinion.
I fully agree with you. That was my point.
BGPsec is coming.
It will take care of the accidental hijacks where people accidentally do this. So it will take care of 90% of the cases. But the ones that are on purpose, they won't work.
We're out of time, so we'll just take one more question.
Yeah, two questions related to our PKI. One, what's the controversy? And then two, did that play into your rule logic in terms of determining whether something was good or bad?
To be honest, it's not integrated today, just because of the adoption of and we ran out of time. But we can easily do it. We have all the data, and again, we do it in our commercial solutions. The controversy. Well, one of the controversies is it doesn't solve all the problems, as you've heard, because it only looks at the origin. So if you spoof the path, it's a well-known BGP traffic engineering technique called AS prepending. You can prepend it with whatever path you want, so then it looks like the origin hasn't changed. Again, that's what happened with the Bitcoin hijacks. The other one is the scaling issue. Like there's many routes out there. Depending on, some routes are very unstable, so you need to validate multiple times per second. Can you do this in the routers that are already running out of memory and CPU all the time? So that's the other controversy.
Thank you. Great. Thank you very much, and enjoy the rest of the Black Hat.
Hello?